Very good evening to everyone. Assalamu alaikum. My name is Asadullah Kamarbati, and with me I have Ji Chuan Ming, Umi Haini Ainan, and Grace Tong Pi Chu. Today, our presentation is about the classwork related to deep learning and LLM guided personalized care for early oral cancer detection. So, we have done a few different sections related to this to test our skills that we have acquired in the Advanced Research Methodologies course. So, this is the overview. These are the sections that we will be covering today: research field, research problem, research objectives, research questions, variables, data collection methods, and data analysis techniques. In the research field, it's not specifically computer science or medical field on its own, but it's a merger of the two fields of artificial intelligence in healthcare. And then we can zoom in further to medical image analysis using deep learning. And then specifically within this scope is on LLM-guided personalized care for early oral cancer detection via mobile-based screening. Okay, so the research problem, essentially oral cancer remains a global health concern. So late diagnosis leads to poor survival outcomes. Mobile-based screening offers promising detection solution. Deep learning enables accurate oral image analysis, and LLMs provide personalized, understandable health guidance. And we need a system to combine detection and explainability together. So that's what this whole project is about, or research is all about. So there are 4 research objectives aligned to 4 research questions, and these are the research objectives. So I'll give a quick call out on a few of them. So for the descriptive is to develop a deep learning based model for detecting oral cancer from mouth images. And the question is how to develop a deep learning model to accurately detect early signs of oral cancer from mouth images. And then for the experimental is more on to evaluate the performance of the deep learning model and compare it with other studies. So then the question here is how does the performance of the deep learning model compare to existing approaches? So there are 4. I won't go over all of them in the interest of time. Okay. And then for variables, we have independent and dependent for experimental and descriptive. So on the left is experimental, on the right is descriptive, and independent is on the top and independent is on the bottom. So essentially the objective for experimental research variables is like to evaluate how well the mobile-based systems performs in detecting early signs of oral cancer and how the inclusion of LLM-guided care affects system outcomes. So independent, like what you need to track and view is the type of image classification model and use of LLM-guided personalized care. This is what we are changing. And then we interpret what is the respondent or the dependent variable, what is the outcomes, we look at the detection accuracy, system efficiency, and quality of the system output. So we are basically evaluating whether when we change a specific image classification model, does it improve the detection accuracy or not? And we'll try different variations. And then for the descriptive research, we have type of systems used by participants and user background characteristics. And the dependent is user understanding, user trust, perceived usefulness, behavioral intention, and usability and satisfaction. So to explain a bit more, what we're doing is we're changing the approach that we are using to teach the students about early oral cancer and how we're basically equipping them with knowledge. So maybe if it's just a simple visual, like a graphic or a infographic, then maybe the outcomes are not as good. But if you use LLMs, like if they're chatting a lot with LLMs, when we check their responsiveness to healthcare and when they come on in for appointments on time, then we are able to track that there's more efficacy of the type of system used by the participant. So for data collection strategy, we have experimental and descriptive. So the data collection strategy for experimental is oral image data model development. So we need to access publicly available data sets like ORCID, OLID, Kaggle. Don't ask me what this is. Probably my team member will have to add more on this. But to ensure reproducibility and pre-processing images resized to a specific set dimensions of 224 pixels to 224 pixels and normalized for consistency, and also augmentation to rotate, flip, and illuminate changes to simulate mobile photography conditions. And then for the user study data system evaluation, basically we're assessing whether the user is able to respond better to different modes of education. So we're using experimental design of randomized comparison between control groups. So visual only is the control group and experimental group is the LLM guided group. And then We implement structured post-experiment questionnaires using a 5-point Likert scale. So then we give them a survey, and then they answer and then we check how accurate their answers are, how confident they feel about the quiz that we've given them, the survey. And then of course we check okay, out of 40 questions, maybe they got 39 correct, and they have a very good score, meaning they are actually very knowledgeable about oral cancer. So that means LLM was probably more effective. And then we probably use some kind of, as I'll go in the next session, some Mann-Whitney U test or some kind of U test to compare the two populations of control group and experimental group to confirm that they actually have a statistically significant improvement. Okay, finally, we go into the data analysis. So we have experimental and descriptive as well. So as we separated, the experimental is more on the model performance analysis, where we're doing different interventions where we're doing different algorithms and models in variations, and we're checking their responsiveness in terms of the accuracy, precision, recall, and app1 score. And then efficiency metrics assessed to ensure mobile feasibility, measuring inference time, processing speed. So basically how fast the model is on a mobile device, because when you use a mobile phone, you don't want to wait so long. You take a picture and you have to wait so long for the result to come out. So we want to make it quick, like measuring the inference time. That's what it means. The model complexity also, shouldn't be too big as a model, like a terabytes model that can fit on a mobile device, or if it needs to be using cloud, that will be determined. And resource utilization is also important on a mobile device because RAM and CPU is limited on a mobile device. And then finally, for statistical analysis of user study, which is descriptive, we're going to use hypothesis testing, which is independent t-tests, and Mann-Whitney U-tests to conduct statistical confidence tests to compare control population experimental LLM-guided groups. And of course, we will assess the impact by analyzing significant differences in key user outcomes. So maybe across a few dimensions, we'll check the statistical significance of significant difference, and try to measure which areas LLM is most effective in improving, whether it is comprehension, trust, or behavioral intention. We could find that trust actually degrades with LLM, but comprehension increases. But that is to be proven by the research itself.